Good evening, all. I welcome you all on the behalf of StudyIQ IAS English. My name is Pritesh Maturkar. I extend my warmest regards to everyone, those who are watching me live for the very first time, as well as those of you who are continuing this journey with me. I extend my heartfelt wishes and my warmest blessings to everyone. I welcome you all to lecture number 20. So, we have come rather a very long way in this journey, and we have also traversed a lot of locations. We have also traversed lots of geophysics of earth. So I hope that you and I are in consonance, you and I are moving side by side, and that you are getting enriched by this content. Okay, so in this curriculum or in this series, I, as your able mentor, philosopher and guide, is taking you on a world tour wherein, using the basics of geography, we are trying to analyze the maps being the most potent tool of geography. So using maps, we will be also learning the important principles of geophysics. So I intend to cover roughly 50 to 60% of your geography GS discourse using this curriculum, and this curriculum will help you in also understanding the advanced level concepts which are required for the civil services mains perspective. And in this series, I will be focusing on locations primarily, so locational analysis and interlinkage. So using these lectures, I will be roughly targeting 10 to 20 marks in prelims and approximately 100 to 200 marks in mains. And if you have geography based questions, you have ecology based questions, and if you have environmental based questions more in GS paper 1 and GS paper 3, then you can have this scoring increasing up to 300 to 400 marks too. So I'm basically targeting these lectures from a utilitarian perspective, wherein I'm also giving you concepts, we are seeing the locations, and we are also analyzing the current affairs too. Okay, so the typical workflow of these sessions is this: that in first 5 to 10 minutes I discuss whatever we did in the previous class, and then I introduce you to new concepts, and thereafter we try to map it on the atlas. Okay, so today being the 20th session, it gives me my utmost privilege that you have shown this trust in me. I have been revering it a lot, and I will revere it forever, that you have put such immense trust in me and that you are patient with me, because though the series is titled Geography Through Maps, yet we have not started the detailed analysis of maps. Why, guys? Because this will require some groundwork. Okay, so today and most probably tomorrow, or at max day after tomorrow, but not day after tomorrow complete lecture, not more than 15-20 minutes, this will lay our foundation work. So in day after tomorrow's lecture, you can expect that we will start the location analysis of the first country of the world. So I will be moving by country, continent, then big continent, then pan region. So on Saturday, you can expect that we can start the analysis of New Zealand per se. So therein you will start enjoying these sessions even further, because the true world tour will begin. And mind you, this world tour is free of cost. Okay, the cost basically is incurred by me, but you will have to repay me. In what sense? You will have to get a good all India rank. That is how you will repay me. Okay, jokes aside, jokes means my cost, not your cost. You have to incur that cost. You have to give me a good all India rank, and that is the bigger endeavor of StudyIQ IAS English. So let's start from where we left in the previous class, and as promised, each lecture will begin with a beautiful image of a location which we did in the previous class. So the image which you are seeing on this interactive flat panel, this image is basically of Iceland. Okay, so if you observe this, so there is this rift, and between this rift you have a water body and you have two distinct land masses. So guys, you know what are these land masses? This is basically the North American plate, and this is basically the Eurasian plate. So if you go to Iceland, you can practically see the split up of the American plate and the Eurasian plate. So on one side towards the west, you will have the North American plate moving, and on this side you will have the Eurasian plate drifting. So the boundary over this is called as divergent boundary. So today I will be going into details of the plate tectonics, where we try to understand the different types of boundaries which will be needing for understanding the different locations. Dare I say, the first lecture that we have of New Zealand, so there we will be having a detailed discussion of the boundaries of the plate tectonics of New Zealand. So therein this discussion will come in handy. But this is a very beautiful location in Iceland wherein you can see the split of two continental plates. So this is the North American plate and this over here is the Eurasian plate. Okay. And guys, this in general is the beauty of this discipline, that you can actually see, you can actually feel, okay, you can actually contemplate in reality whatever we are studying. So hats off to this discipline and hats off to the founders of this discipline. Because of them we are able to understand and appreciate the beauty of our planet. See how beautiful this location is. Okay, so let's start from where we left in the last class. So in the last class I did introduce you to plate tectonics. I did introduce you to the concept of lithosphere drifting over the semi-molten asthenosphere. Why do you have that? Why do you have the lithosphere drifting over the semi-molten asthenosphere? Because the asthenosphere has got a mineral called as olivine. So the asthenosphere, okay, the asthenosphere will have which mineral? It will have the mineral called as olivine, and olivine will do what? Olivine will lose rigidity. It will lose rigidity under sustained stress. So as it loses rigidity under sustained stress, so the lithosphere basically drifts or floats on the semi-molten asthenosphere. So lithosphere basically drifts and floats over the semi-molten asthenosphere. Okay. And mind you, the lithosphere is not one continuous layer. The lithosphere is like a broken eggshell. So if you see the diagram of lithosphere, if I'm showcasing you all the lithosphere, so the lithosphere is broken. Okay, it is broken into segments like this. Okay, so you have different pieces, different fragments of lithosphere broken like this. Okay, and each of this piece, okay, each of this fragment, this is called as lithospheric plate. This is called as lithospheric plate, and each of these fragments, each of these plates, they basically drift over the semi-molten asthenosphere. And because of this we have continents colliding, continents drifting. You have different types of plate boundary interactions. So today we'll venture into that, and I did explain you some of the major plates and some of the minor plates. So the lithospheric plates are basically grouped into major plates and they are grouped into minor plates. So you have major plates and you have minor plates. And the lithospheric plates, you can have both continental plus oceanic. So you can have lithospheric continental plate or you can have lithospheric oceanic plate. Normally you have a combination of C plus O. Okay, you do have continental plate existing in individuality, you do have oceanic plate existing in individuality, but normally it is found that it is a combination of C plus O. So after the continental plate you will have the oceanic margins, but mind you, the continental crust is not as same as the oceanic crust. You must keep this in mind. Okay, the continental crust is not as same as the oceanic crust. Okay, the continental crust is more fundamental, okay, is more fundamental? No, continental crust is not fundamental. Dare I say the oceanic crust is more fundamental. Then you will be saying me, sir, how come the continental crust you are finding and you are not finding oceanic crust, or how are you doing this, or what are you saying, how is this possible? So please understand, the continental crust once formed can never be destroyed, okay. Why? Because continental crust is buoyant, it resists subduction, whereas the oceanic crust gets destroyed, it gets melted, it subducts, it melts, and it gets recycled, and that cycle is called as Wilson cycle. Okay, and this recycling, this melting, this subducting happens at trench locations. So today we will discuss what do you mean by trench locations, so don't worry. So basically the oceanic crust is more fundamental crust than the continental crust, but as the oceanic crust gets subducted, it melts and it gets recycled, so we do not have oceanic crust older than the era of the dinosaurs. It is called as Mesozoic and Cretaceous, so we don't have the oceanic crust older than the mid Mesozoic times. You can, for your reference, you can remember it to be the era of dinosaurs. So Prior to that, we don't have the oceanic crust, but continental crust we have very old. But the oceanic crust is more fundamental. Please keep this in mind. Okay. So now let's move forward. So we discuss the major plates and we discuss the minor plates. So major plates, you can have continental, you can have oceanic. Minor plates also, you can have continental, you can have oceanic. Normally they exist as a combination of C plus O. So now let us try to use map and try to understand what are the major plates of the world. So for this, I will be using an atlas. So let's try to again understand the plates. Let's try to do a quick revision of the plates per se. So quickly, I'm revising the plates for you. Quickly, we are focusing on the different tectonic plates of the world. Okay. So if I consider first the major plates of the world, okay, the major plates of the world. So in the first major plate, let us consider the world's biggest plate. Okay, which is the world's biggest plate? The world's biggest plate is the Pacific plate. Okay, this is the world's biggest plate, Pacific plate. And mind you, Pacific plate is also the world's biggest oceanic plate. So the Pacific plate is the world's biggest plate as well as it is the world's biggest oceanic plate. So you can see Pacific plate over here and you can also see Pacific plate coming over here. So this and this is the Pacific plate. So the biggest continental plate of the world, sorry, my bad, the biggest oceanic plate of the world as well as the world's biggest plate. Okay, then you have the world's biggest continental plate called as the Eurasian plate. Okay, so this is our Eurasian plate. See this complete plate over here, this is called as Eurasian plate. Okay, so this complete plate, this is our Eurasian plate. So world's biggest continental plate. Then you have the North American plate, you have the South American plate. Sorry, this is not African, this is South American. So you have the North American plate, you have the South American plate, then you have the African plate, and then you have the Indo-Austral plate, and lastly you also have the Antarctic plate. So the major plates of the world: Pacific plate, Eurasian plate. Pacific plate is the world's biggest plate as well as the world's biggest oceanic plate, purely oceanic. Okay, the world's biggest continental plate is the Eurasian plate, but mind you, Eurasian plate does have oceanic margins too. So see this complete is the oceanic margin of the Eurasian plate. Okay, then you have the North American plate, you have the South American plate, you have the African plate, and lastly you have the Indo-Austral plate including the Indian plate. Okay, so basically Indo-Austral plate is taken as one, Indian plate is not treated as separate. So this complete combination, this is referred to as the Indo-Austral plate. Okay, so now these are the major plates of the world. Now let us focus on some of the minor plates. So I did discuss some of the minor plates with you. So over here you can see the Arabian plate. Okay, so this is our Arabian plate, one of the major minor plates of the world. So as the Red Sea formed between Africa and Saudi Arabia, you had this differentiation between the African plate and the Saudi Arabian plate. So basically there was a divergent boundary formation because of underwater hotspot volcanism, because of domal uplifting. Don't get frightened of these words, guys. Eventually you will get accustomed to these words. Okay, these words are important from a technical perspective, so eventually you will get the hang of this word. So for now, just understand that the Saudi Arabian Peninsula and the Africa were joined. You remember the breakup of Pangaea we did? So then something happened, you had a rifting. So the land mass is separated and you have formation of Red Sea. And mind you, this rifting is now continuing. It is not that this rifting has stopped per se. Okay, so this rifting is still continuing. Okay, then you have one of the most important plates of the world, the Philippine plate. After that, you have another very important plate towards the tip of South America. You have the Scotia plate. Between North American plate and the South American plate, you have the Caribbean plate. So this is our Caribbean plate. Then you have Cocos plate and you have Nazca plate. Okay, so Cocos plate, Nazca plate, Caribbean plate, you have the Arabian plate and you have the Philippines plate. And over here you again have a very small plate. This is called as Juan de Fuca. This is called as Juan de Fuca. Okay, very small plate, but this is called as Juandi Fuka. So guys, these are some of the major and minor plates of the world. I hope that using this interactive kind of learning, you are comfortable with the locations. And as I said guys before, you need to have Orient Black Swan School Atlas ready with you. So from tomorrow onwards, or maximum from day after tomorrow onwards, please keep Orient Black Swan with you so that we can have in detailed analysis, in detailed coverage of all the locations. Okay, so let's move ahead. Now let us start our today's class. Okay. So today I'm teaching you the most important topic, the types of plate boundaries and the associated features. Okay. So we did discuss that you have this lithospheric plates. Okay, this lithospheric plates, they can either have convergent boundary, they can either have divergent boundary, or these lithospheric plates, they can just slip past one another. So you can also have transformative boundaries. These lithospheric plates are floating over the semi-molten asthenosphere. As they float, as they drift, you have this interaction. So if anybody asks you, sir, madam, comment on the lithospheric plate interactions. So the lithospheric plate interactions are of three types primarily. Okay, so the lithospheric plate interactions, the lithospheric plate interactions, the lithospheric plate interactions are of three types. Okay. Okay. Number first, you have divergent interactions. You have divergent interactions. You have convergent interactions. Okay. Convergent interactions. Okay. After that, you have transform interactions. Okay. Transform interactions. Okay. So if we consider the divergent interactions, so in divergent interactions, two lithospheric plates will move apart from one another. In convergent interactions, two lithospheric plates will collide with one another, and in transform interactions, these lithospheric plates, they will just slip past one another. Okay, so let us now discuss the most important divergent interaction of the world and what are the features of divergent boundaries. Okay, so if I'm discussing the divergent interactions with you all, okay, so the divergent interactions is where you have the fracturing of the continent. So imagine that this is a continental slab like this. Okay, beneath this you will have a volcanic plume like this. So you remember the Arthur Holmes convection cell hypothesis. So below this you will have a volcanic plume. This volcanic plume will result into what? This volcanic plume will result into domal upliftment like this. Okay, so here you can now have localized volcanism like this. Okay, after this, so after this part of the Earth's lithosphere will start to stretch, will start to thin. It will stretch, it will thin, and then finally it will rift apart. So after this, the stretching, thinning starts of the lithospheric plate. So when it starts to stretch, when it starts to thin like this, so you will have interaction like this. It starts to stretch, it starts to thin, and as it starts to stretch, as it starts to thin, over here you can have formation of a nascent sea. You can have formation of a nascent sea or ocean. Okay, nascent means fairly new. So you remember South Africa, you remember South America, sorry, my bad, you remember Africa and Saudi Arabia. So between Saudi Arabia and Africa, you have formation of Red Sea. You have formation of Red Sea. Let me just open up the map again so that you are comfortable with that. Okay. Okay, let me open it up so that you have a bird's eye view of what I'm talking about. Okay, so let me just open up the map of Earth for you all. Okay. Okay, so if you can see on this map over here, so if you can see this Red Sea basically, So this Red Sea has formed when on one side you have stretching and thinning of the African plate like this, and on one side you had stretching and thinning of the Saudi Arabian plate, and below this you had a divergent interaction like this. So because of this, the land starts to thin, and here you have formation of a nascent ocean called as Red Sea. So on one side the Africa is drifting, and on other side the Saudi Arabian peninsula is drifting. So because of this, you have formation of a nascent ocean over here called as the Red Sea. Okay, this is very interesting, guys, that these are the stages of divergent boundary formation. After this, once this happens, once this rift starts, then finally these continents get pulled apart fully. So once it happens, so on the one side you will have what? On the one side you will have one continent, on the other side you will have another continent, and in between now you will have a vast ocean. And in between you will have a vast ocean. So these are the stages of proper divergent boundary formation. So it will all start with a volcanic plume. The continents will start drifting apart from one another, and as they start drifting from one another, so they will get stretched, they will get thin, and as they get stretching and thin, because of this, in the middle you can have formation of nascent ocean. Then finally all of these continents, all of this landmass is pulled apart, and in the middle you have ocean. So whenever you have the continental phase of stretching, thinning and drifting, whenever you have this volcanic plume, so on the ocean bed you have a very distinct property of divergent boundary. It is called as mid-oceanic ridge. So if I take down into the bottom, if you take down into the bottom of the sea, so at the bottom of the sea you will see something like this. So this is basically called as mid-oceanic ridge. So this is called as mid-oceanic ridge. So over here you will have what? You will have one volcanic plume like this, another volcanic plume like this. So this is rising and diverging vertical convection cell. So at the bottom of the oceans you will have topography like this, wherever you will have divergent boundaries. So the volcanic plume is coming, it is drifting and drifting in this direction, this is drifting and drifting in this direction, resulting into the formation of a ridge called as mid-oceanic ridge. Please get this very, very properly. And across the mid-oceanic ridge you will have volcanism like this. So basically the mid-oceanic ridges are the locations of ocean floor creation. I'm again reiterating. So as this Red Sea has drifted, as the Atlantic Ocean is now drifting, so in the middle of Atlantic Ocean you will have a mid-oceanic ridge which is pushing the oceanic plates of North America and Eurasia apart, and this we call as mid-oceanic ridge. So mid-oceanic ridge basically are the locations of ocean floor creation. So wherever you will have divergent boundary interactions wherein you have the formation of there you will have the formation of ocean floor, and from this the ocean floor will be drifted apart. So now let us try to analyze it on the map. So for that I'm again using the map for you all, so that you get a bird's eye view of what I'm telling. Guys, you are all incredibly lucky that you are all able to get this knowledge in such interactive way. Okay, so it's my humble request that you all please get whatever I'm talking about in the best possible way. Okay, so let us again use this map. Let us again okay, so I'm again focusing on this map so that you get a bird's eye view of what I'm talking about. So if I take you to middle of Atlantic Ocean, if you see this part, okay, this complete boundary, okay, so this complete boundary, this is called as what? This is called as mid-oceanic ridge. So this complete boundary, this is referred to as more. As you can see here, the arrow is pointing in this direction, indicating what? That this land masses are getting separated. So this is called as divergent boundary. So wherever you are seeing this arrow, this will indicate what, that these are the locations of divergent boundary, where the ocean floor is being created and it is being drifted apart. Okay, so these are the locations of the divergent boundary. So in the middle of Atlantic you have a more, okay, on the southwestern edge of Pacific you have more, okay, towards the southeastern edge of Atlantic you do have more, okay, towards the southwestern edge of Indo-Austral plate you again have a more. More means what? Mid-oceanic ridge, wherein you have underwater volcanism, and along the mid-oceanic ridge you will have what? A rift valley, an actual rift valley along which the ocean floor, new ocean floor is created. So along the mid-oceanic ridge the lava will come out, it will spread, and it will basically drift into directions because of the underwater rising and diverging convection cells as given by the Arthur Holmes. Very easy to understand, very simple to understand. Just keep this in mind, that whenever we will have the divergent boundary interaction, so there you will have the formation of the mid-oceanic ridges. So a proper divergent boundary will always have a mid-oceanic ridge in the middle. Okay, so this summarizes the divergent boundary for you all. Now mind you guys, okay, divergent boundary means what? That the two plates are moving apart from one another. So you have divergent boundary in the middle of Atlantic, you have divergent boundary in the southwestern Pacific, you have divergent boundary along the southeastern Atlantic too, and you have divergent boundary in the southwestern Indo-Austral plate too. But along this divergent boundary you will also have some locations which will incessantly have volcanism. What do you mean by this? So along this mores you will have small fractures. In these fractures, in these zones, you will have continuous continuous pouring out of magma. So along the more where you have continuous pouring out of magma, such locations are called as hotspots. So in the meantime, like when we will start discussing the atlas, I will also be focusing on what do you mean by hotspots, what do you mean by hotspot volcanism. So for now, just remember that along the mores you may have hotspots too. Okay, so what are mores? Mores are the locations, the mid-oceanic ridge are the locations of ocean floor creation. So where do you have more? You have more in the middle of Atlantic, you have more in the southwestern Pacific, you have more in the southwestern Indo-Austral plate, and you have more in the southeastern Atlantic too. So these are the locations of the more, and every divergent boundary will have what? It will have a proper more. So the divergent boundary interaction will start from what? I'm again reiterating. Okay, so the divergent boundary interaction will start from this. Okay, you have a localized volcanic plume beneath the continent. Because of this, the continent will uplift. This stage is called as domal upliftment. This stage is called as domal upliftment. After this, after domal upliftment, the two continents, or the continent will start to stretch, it will start to thin, it will start to rift, resulting into formation of nascent sea. Okay, so you remember the Red Sea which I showcased you? So this is it. After this, you will have the proper boundary of the ocean forming, and beneath that you will have a mid-oceanic ridge. Okay, so the mid-oceanic ridge is nothing but an axial rift valley wherein you are having continuous pouring out of magma, and these are the locations of ocean floor creation. Okay, and wherever you will have divergent boundaries in the oceans, you will have more locations. Okay, some of the divergent boundaries will be very active, some of the divergent boundaries will not be that active. Okay, so if I'm discussing the plate interactions with you, so number first, I did discuss the divergent interactions which start from domal upliftment and they end up in the formation of proper more. Now let us understand convergent interactions, because these interactions of very much of prominence, and in convergent interactions two lithospheric plates basically they collide with one another. So let us understand how does this happen and what are the properties associated with each of the convergent boundary interaction. So let's move ahead, let us discuss the convergent boundary interaction. Okay. So if I'm discussing the convergent boundary interactions with you all, Okay, convergent boundary interactions with you all. So convergent boundary interactions are grouped into three. Number first, you have oceanic margins, wherein two oceanic plates collide with one another and one of it subducts. Number two, where you have the oceanic continental margins. So first you will have OO margins. The first in the sequence of convergent boundary will be the O margins, the second in the sequence will be the OC margins, and the third in the sequence, when complete both of the oceanic plates have been completely subducted, lastly you will have CC margins. Two continental plates will now come face to face. Okay, so guys, this becomes very important that you understand all of this. What do you mean by OO margins, what do you mean by OC margins, and what do you mean by CC margins? Guys, now I'm focusing only on the preliminary aspects. Okay, I'm not going into the details. Okay, the details will be done when we will do the complete GS discourse. Now I'm doing only that part which is important for me, for you, making understand the atlas. Okay, so it's like I'm taking undue advantage of plate tectonics. It's like that I am basically advocating that you have this knowledge so that we can move ahead and we can understand the maps better. Okay, so let us understand what do you mean by OO margins, wherein you have interaction of two oceanic plates. Okay, so again I'm opening up the map for you all. Okay, so if I open up the map for you all, and if you see this area, okay, okay, if you see this area of Pacific and this area of Philippine plate, and if you see this area of Pacific and this area of Indo-Austral plate, so this area and this area is where you predominantly have OO interaction. This area is where you have predominantly O interaction. If I consider this plate, this side of Pacific plate, so Pacific plate colliding with Cocos plate, again O interaction. Pacific plate colliding with Nazca plate, again which kind of interaction? O interaction. But mind you, this is a divergent boundary. Over here this is not convergent boundary, so this is a divergent boundary. So this is not done. So Pacific plate's convergent boundary with Cocos plate is there, Pacific plate's convergent boundary with Philippines plate is there, but Pacific plate does not collide with Indo-Austral plate in this part, it collides in the southern part. So if you ask me, where do you have the OO margins of Pacific plate? So you majorly have with the Philippine plate. Down south you have with New Zealand. This is not evident in this part, but after Australia you have New Zealand. In New Zealand you do have the OO convergent boundary, and Pacific plate does share convergent boundary with Cocos plate. So these are the three primary locations where the Pacific plate subducts underneath the Philippines plate, underneath the Cocos plate, and somewhere also underneath the Nazca plate. So whenever this subduction happens, so there are certain aspects to this, there are certain terminologies to this. So let us understand what are these terminologies, let us understand what are these aspects. Okay. So I am discussing the first sequence with you all, the OO margins. Okay, the oceanic interaction. So now just imagine that this is one oceanic plate like this. So this is one oceanic plate. Okay, and you have another oceanic plate, and this oceanic plate is subducting underneath this oceanic plate. So this is another oceanic plate, this oceanic plate is now subducting underneath this plate. So you have pulling inside the mantle like this. So you have converging and sinking. When you had a divergent boundary, so you had rising and diverging. Here you have converging and sinking volcanic limbs. So the Arthur Holmes convection cell hypothesis. So now because of this limb being more active, the oceanic plate, this oceanic plate being more heavy, this oceanic plate being more dense, it is now being pulled into the mantle. Now as it is being pulled into the mantle, what will happen at this boundary? So if I'm extending it in 3D like this, so just imagine that this is the 3D representation of this margin like this. So what will happen at this? As this oceanic plate is subducted into the mantle, as this oceanic plate is being pulled into the mantle, So along this boundary, you will have plastering of sediments of the subducting slab. Along this slab, the sediments of this subducting slab will get plastered, right? And this sediments which are plastered of the subducting slab, this is called as what? This is called as accretionary prism. This is called as accretionary. This is called as accretionary prism. Okay. What do you mean by accretionary prism? Accretionary prism is that sedimentary accumulation of what? Of the subducting oceanic slab. And where this subduction occurs, where this ocean slab is pulled into the mantle, this area, this complete area, this is called as trench location. This is called as what? Trench. So what are trench location? Trench location are those areas where subduction occurs. Where subduction occurs. Where subduction occurs. Okay, please keep this in mind. These are the locations where subduction occurs. And now, as this ocean slab is being pulled into the mantle, as this ocean slab is subducting, so some of it will melt, it will rise up, it will come above, and here it will now form volcanic archipelagos. Here it will now form volcanic archipelagos like this. So, on the subducting ocean slab, as it melts, its sediments will come up. As they melt, they will rise up, and here they will form long linear chains of volcanic islands on the other oceanic slab. And these are called as what? These are called as volcanic archipelagos. These are called as volcanic archipelagos. So all of this will be needing, guys. I know this is a little bit daunting, but you need to understand that what are volcanic archipelagos. So the sediments of the subducting ocean slab which melt, they basically rise up, they basically form this long linear chain of volcanic islands. And hence, as they are formed on the other ocean slab, so on the east or on the this side of this volcanic archipelagos, you will have accretionary prism and you will have the trench location. So if I'm painting a 2D picture for you, this was a 3D picture. So if now I'm painting a 2D picture for you all, so imagine this is one slab. Over here you have volcanic archipelago like this. Okay, you have volcanic archipelagos like this. So you are done with this archipelago. After this you have what? You have accretionary prism. You have accretionary prism, and you have what? You have the trench locations. So you have accretionary prism and you have trench locations. So you have trench and accretionary prism. So anything after the volcanic archipelago, this is called as forearc. Please remember this. This is called as forearc. Anything to the back side of volcanic archipelago, it will be called as back arc. So anything ahead of it, it will be called as forearc. Anything back of it, it will be called as back arc. So the forearc will have what? The forearc will have accretionary prism and the trench, whereas back arc, the back arc basin of such boundaries will have what? It will have predominantly the marginal seas. It will have predominantly the marginal seas. Guys, this is very important when we will do the map of Asia. So I'm again reiterating, what are marginal seas? The area to the backside of volcanic archipelagos. How are these volcanic archipelagos formed? So whenever this ocean slab is subducting, one ocean slab is subducting underneath the another ocean slab, so it will melt, it will rise up, forming long linear chain of volcanic islands called as volcanic archipelagos. So anything ahead of that, it will be called as forearc. Anything to the back of it will be called as back arc. Okay, so the forearc will have what? The forearc will have the accretionary prism and the trench locations, whereas the back arc, it will have what? The back arc will have the marginal seas. And these entries will be very important when we will do the Atlas of Asia. So this is very important from the OO convergent interaction. Now let us move ahead. So now one ocean slab has completely subducted. Now the ocean slab is coming face to face with the continental slab, and now what will happen? You all know that the continental slab will resist subduction. So now the oceanic slab will get pulled into the mantle. So now let us understand the second sequence of convergent boundary interaction, that is OC convergence. That is OC convergence. Okay. Now the oceanic slab is coming face to face with the continental slab. Okay. So imagine this is a continental slab. Okay, this is a continental slab, and now the oceanic slab is coming face to face, and now the oceanic slab is being pulled into the mantle like this. Is being pulled into the mantle like this. So this will be our oceanic slab like this. Okay, and here you will again have the continental margin. So this will be our continental margins. Okay, so these will be our continental margins. This is the oceanic slab. So this is our continental plate and this is our oceanic plate. Now this oceanic plate is being pulled into the mantle like this. Now what is happening at the trench location? What is happening at the zone of subduction? So at the zone of subduction, now what will happen? You will again have plastering, but mind you, this plastering will now have what? Now here not only the pieces of the subducting ocean slab will be chopped, will be plastered over here, but here the pieces of continental slab too will get plastered. Okay, when we had the OO kind of convergence, there only the pieces, there only the fragments of the subducting ocean slab were being plastered underneath the other ocean slab. But now here what will happen? Not only the pieces of the subducting ocean slab will get plastered, but also the pieces of the continental slab. And mind you, this mixture will also include the older accretionary prism, because before this boundary you had OO boundary. So this new chaotic mixture along this trench location, wherein you have plastering of sediments, this is called as melange. This is called as what? Melange. I will make you understand what do you mean by melange. So what is melange, guys? So melange is the new chaotic mixture, or it is the new accretionary prism which forms because of plastering, because of chirping of the different plates at the OC margins. So it is basically the new accretionary prism. Okay, it will include what? It will include number first. Okay, it will include number first the sediments of the subducting ocean slab, of the subducting ocean slab. So this is the first thing which it will include. After that, it will also include the sediments. Rather the chirping. Okay, the chirping of the continental slab too, because now the boundary is oceanic and continental. And number 3, it will also include older accretionary prism, plus it will also include older volcanic archipelagos. So this new chaotic mixture is called as melange. This melange will rise up as the plate gets subducted, as everything gets plastered. This melange will now rise up as long linear chains of mountains, and hence we have the upliftment of the Andes. So what is happening at the Andes? Basically what is happening at the western boundary of South America is the subduction of Nazca plate underneath the South American plate, guys. So this is very, very important. So this is called as melange. So this is the second sequence of the convergent boundary interaction. This is called as OC convergence. Now let us understand the third sequence of interaction. The third sequence of convergent boundary interaction will be the CC convergence. Now in CC convergence, what will happen? Both the continents' oceanic margins are now completely subducted. Now two continental slabs are coming face to face. Now, as they are coming face to face, you will have intense compressive forces. Because of this, you have upliftment of which kind of mountains? You will have upliftment of fold mountains. So you will have folds like this. So this folds will rise up as what? It will rise up as fold mountains. So whenever you will have convergent boundary interactions, these interactions will have immense compressive forces and you will have formations of the folds and hence the fold mountain. And the most common example of this is the India's interaction with the Eurasia. So Indian plate is colliding with the Eurasian plate, resulting into upliftment of Himalayas. Okay. So this was the third sequence in terms of the convergent boundary interaction. So if I'm painting a crisscross comparison of all the three interactions, let us do a tabular format so that you get a hang of it, what we have done. So the convergent interactions are of three types. Okay, the convergent interactions are of three types. Let us do a crisscross comparison between this. So on one side, I'm discussing OO, the first in sequence. Second, I'm discussing OC. And third, I'm discussing CC. So in the first point, you will have what? You will have the accumulation of accretionary prism. Okay, this accretionary prism will have only the sediments of the subducting oceanic slab. Okay, then you will have formation of volcanic archipelagos. Why? Because as the oceanic slab will melt, as the oceanic slab will subduct, it will rise up to form long linear chains of volcanic islands. Okay, you will have forearc, you will have back arc. So the back arc will have marginal seas, whereas the forearc will have the accretionary prism and it will have the zone of subduction, that is the trench location. And the OO boundary will always have volcanism. Okay, it will have high volcanism, but mind you, this volcanism does not mean that you will have high seismicity. Rather, the volcanic eruptions at OO boundaries are very gentle. Why? Because primarily you have basaltic eruptions over there. The magma associated is not that violent. So volcanism is very high, but the seismicity, okay, the intensity of earthquake is less. The seismicity of earthquake is very less. Now, when you consider the O margins, instead of accretionary prism, now you have melange. This melange will rise up to form long linear chains of fold mountains, long linear chains of mountains like the Andes. Okay, here you won't have volcanic archipelagos, but here you can have the formation of the Andean type of mountains. Okay, the Andes of South America. Here the volcanism and seismicity will be both, okay, will be both present and both will be in an increasing territory. Increasing territory means what? That volcanism will be not as potent, not as lethal as the O boundary, but the seismicity will be more than the O boundary because here you have continental plate. So the frictional forces will be more. Okay. Then lastly, if I am considering the CC boundary, so here you will have folds forming. These folds will basically rise up into long linear chains of fold mountains, and you can have different types of folds over here. You can have recumbent fold, you will have overturned folds, but don't need to worry, we don't need to discuss that. Okay, here you will have formation of proper fold mountains of the world. Okay, you will have proper fold mountains of the world. So you remember we discussed the Caledonian mountains, the Hercynian mountains, the tertiary alpine mountain building phase, the Rockies, the Andes, and then you also have the Trans-Eurasian alpine mountain system. So basically Andes, they form a part of OC collision, but rest of the mountains, they form the part of CC collision. And lastly, here volcanism will not be present, but seismicity will be very high, but seismicity will be extremely high. So today if you go to Himalayas, you won't find volcanism, but you will find very high seismicity. So guys, this was very important that we did discuss this. And the last kind of interaction that we have, it is called as the transform boundary interaction. It is called as the transform boundary interaction. This is called as the transform boundary interaction, wherein the two lithospheric plates just slip past one another. Okay, wherein the two lithospheric plates just slip past one another. There is no sort of subduction. So along such boundaries you will have not volcanism, is you won't find volcanism, but you will have high seismicity. So you can have earthquakes over here. Okay, so you can definitely have earthquakes. So guys, these were the interactions with regards to the lithospheric plates. So you have divergent interactions, you have convergent interactions, and lastly you have transform interactions where the two lithospheric plates just slip past one another. So the Juan de Fuca plate, you remember the Juan de Fuca small plate with the interaction with the North American plate which we discussed earlier. So that is a kind of transform interaction. All of these names guys, all of these locations will again come back when we will start doing the detailed analysis of maps per se. Okay, so today I'm concluding my lecture over here. I hope that you all got this lecture in a proper format. Tomorrow's lecture will be the last lecture in this series, in the way that I will be focusing on the principle. So tomorrow just one lecture on the hydrosphere, just one lecture on the oceanography series, so that we have a bird's eye view, and then day after tomorrow we'll start analyzing the first map of the world, that is New Zealand. Okay, so again I reiterate my name. My name is Pritesh Maturkar. You can reach out to me on Telegram by joining this channel, Geography by Pritesh Maturkar. For joining this channel, you can just do a global search at Geography by Pritesh, wherein I keep on posting the relevant tidbits, where I keep on posting the relevant data with regards to the geography discipline, more so the current affairs. Okay, so on the behalf of StudyIQ IAS English, I extend my warmest regards to everyone. All the best everyone. Please study hard and smart. See you all tomorrow sharply at 5 p.m. Okay, take care everyone. Bye bye.